Good morning, afternoon, evening, everyone. Thank you for joining me today as we explore data persistence and how effortlessly manage it using Bal Persist. So I'm Danesh Kurupu. I'm excited to guide you through this tech talk. So before we begin our dive, let's take a moment to recap the key areas we will be covering in this talk. So our focus will be on exploring the features and benefits of Bal Persist. Uh, so and with the significance on improving the data developer experience and addressing the challenges developer often faced in data persistence. So we will start discussing the core components of Bal Persist, understanding how they work together to provide seamless data persistence solution. To illustrate the practical application of Bal Persist, I will conducting a live demo. During this demonstration, we will write a RESTful service with connection to the database while using the powerful Bal Persist. So this will showcase how Persist simplifies the integration of uh, data persist ability within your application and enhance your productivity and reduce the development efforts and etc. So lastly, we will explore the future development and advancement in Bal Persist. So, as you all know, data persistence plays a critical role in the modern application development, allowing us to reliably store and retrieve information over the time. And as developer, we often encounter challenges when it comes to efficiently managing data, ensuring seamless developer experience. So writing complex SQL queries, dealing with database schemas, mapping object-oriented code to relational database can be time-consuming and error-prone. So that's where the Bal Persist come into play. So Bal Persist is about providing seamless data persistence through the combination of defining a data model and utilizing the generator client API. So what that means is when using Bal Persist, you start by defining your data model. This involves specifying the structures, relationships of your data entities. And by defining a data model, you establish a clear representation of your application data and its associations. So Bal Persist take care of mapping this data model to underlying database tables, abstracting away the complexities of database interaction. So once you have this defined in the data model, the Bal Persist generate a client API to interact with your data. So this generated API acts as a powerful interface between your application code and the database. Okay, so before you dive into the architecture and components of Bal Persist, let's take a moment to explore what Bal Persist offers. So I categorize it into five different categories. So the first one is simplifies data interaction. So this solution eliminates the need of writing low-level and complex SQL queries manually. Instead, developer can work on data modules, data types, and high-level APIs to provided to perform common data operations. The next one is developer productivity. So by abstracting away the details of underlying database and providing more clear interfaces, so this solution enhance the developer productivity. Developer can focus more on your application business logic rather than dealing with the complex database operations. So the next one is data mapping. So the solution handles the data mapping between data-oriented world and the relation database model. So they automatically generate necessary SQL based on the defined data model and take care of data to table mapping. So the next important thing is database independency. That means the solution abstract underlying database system. So allowing developer to switch between databases providers without major code changes. So the consistent and integrity. So the solution provide enforces data consistency and integrity by managing transactions and applying database constraints, etc. Okay, so this diagram show you the high-level overview of the key flows of Bal Persist feature set. So it begins with defining a data model, and Ballerina, the associated tool, offers handling feature for visualizing the data model as the entity relationship diagram. So this visualization aids you to validate the data model and make it easy to comprehend. And once the data model is established, Bal Persist tool steps in to generate the client API. So this generated client API serves a powerful tool to manage data persistence within your application's business logic. So Bal Persist core and the database store connectors handle all the complex database interaction behind the scene and allowing you to focus on your application logic without being burned by the low-level database operation. Okay, let's take a closer look at individual components. Now let's delve with the process of modeling your data in your applications using this Bal Persist tool. As I mentioned before, Bal Persist revolves around the concept of defining a data model, which serve as the foundation of your application's data persistence layer. So this model is where our journey of Bal Persist begins. Okay, so when it comes to modeling your data, the first question may raise is where should I do that? So in Bal Persist, we create a dedicated directory called Persist within the Ballerina root project. Inside this directory, we can model our data using .bal file. So currently, Bal Persist support only one file. For data modeling purposes, this model file serves as a single source of truth in your application data. So it's important to note that this model file is not considered as a part of Ballerina project itself. So instead, it serves as a specific purpose to generate the client APIs for the data persistence. Okay, so moving to the next question, how should we model the data in Bal Persist? The answer is quite simple. So Ballerina Persist leverages the Bal record syntaxes to define the model your data entities. So the record syntaxes create straightforward and cleaner way to represent the structure of your entities. So when you define the fields of your data entity, you can simply use simple types as defined in Ballerina, such as integers, strings, Boolean, etc. Additionally, you have the flexibility to use the other entity type to represent the relationship between the entities. So this allows you to establish association dependencies between the data entities within your application. And there's important to note that we are not supporting the union types and also optional fields here. In Ballerina, there's a key difference between the Ballerina record and the entity. So entity must have at least one identifier field. So this identifier field is designated using the read-only keyword. So indicating that its value is used uniquely identify the record of within the entities. So entities in Bal Persist also have the flexibility to have multiple identifier fields. That is commonly known as composite keys. So that is also supported. So when it comes to associations in Bal Persist, fields with entity types plays a crucial role in modeling the relationships between two entities. So these fields establish a connection and the association enabling the representation of various types of relationships. So the Bal Persist support three primary types of relationships: so one-to-one, one-to-many, and many-to-many. So to establish this bidirectional mapping, the both entity involved in the relationship should have this relation field. So the mapping ensures that the consistency and facilitate the seamless navigation through the related entities. So here the example shows how to add a one-to-many relationship within these two entities. Okay, so there's a Ballerina tooling offers a valuable support for validating the data model against these defined rules. So providing meaningful error messages and code actions to correct the issues. So leveraging the Bal Persist Ballerina tooling greatly simplifies your data model process and make it easy to ensure that the accuracy of the data. And one of the notable feature in Ballerina tool is the ability to generate entity diagram based on the data model you created. So the visualization feature allows you to view the data model in clear diagrammatical representation. So by visualizing the relationship between the entity, you can gain the comprehend understanding of the structure and the association within your data model. And it validates the accuracy of the data model. You can identify potential inconsistencies, issues within the data model, and do the necessary adjustments also. Okay, so now that you understand how you model your data in Persist, let's proceed with the next component, the integrated CLI tooling. So Bal Persist come equipped with a tool to simplify the initialization process and facilitate the generation of client API. Okay, we have two primary commands and one experimental command. So the first command is Bal Persist init command, which allows you to initialize the new Bal Persist project. So you can use the command with two additional parameters to customize your project configuration. So when you're initializing the project, you can define the data source parameters to set the data store you intended to use in your project. The data store, if data store parameter is not provided, we set in memory as by default one, and we also support MySQL, MS SQL, Google Sheets. Additionally, you can specify a module in which you can generate the client APIs, providing by the model parameter. So that will generate all. Otherwise, it will generate in the root module itself. The second parameter in Bal Persist is responsible for generating the client API based on your defined data model. So this command examine the data model and generate necessary source files to facilitate data persistence. So as illustrated in the diagram, the source files are generated under generated directory. And if you specify the module in which you want to generate the client API, so Bal Persist creates a module inside the generated directory and place the generated file within the module. So mainly there are 4 files generated based on the chosen data store. The first one is Bal Persist underscore client Bal file, which serves as the primary interface to interact with the data persist layer. The next one is persist underscore types Bal file that serves as that contains all the derived types necessary for working with the data model. Third one is the config file, which contains all the configuration variables required to establish the connection between the application and the chosen data store. So there's a script file generated with necessary SQL script or lab scripts based on the data store. That will help you to create all the tables and sheets in your data store. Okay, so we have another additional experimental command called Bal Persist migrate that will generate the migration script for any changes you made in the module file. So let's say you have all the project set up, all the tables are created. Now that you need to change your model little bit, so and you don't need to recreate the tables again. So this command will compare your model files and generate all the table script where you can go and execute that and do the changes at DB level. Okay, so now that we have generated the client API, let's explore the functionalities and understand how they can benefit in your applications. So I get a small example here. So the API offers a clean method that align with the structure of the relation of the data model. So let's say, for example, we have an employee record. The entity, it will create a resource inside our client object and set of resource functions to do the CRUD operation. Okay, so let's move into the demonstration. I'll move it to my other view. I'll Here in this demonstration, my use case is an hospital service. Hospital has doctors, patients, and the patient can do appointments. So through entities, two data model, we have three data models. One is doctor, patient, and the appointment. Okay, so now I already created a Ballerina project and I inserted three new files here for me to help you in the demonstration. So please ignore for now, then for now. So in order to initialize the Bal Persist, like I said earlier, I need bd Bal Persist init command. So I need to, I'm going to set the module TP where we want to generate all the client API, and I'm going to use data store as MySQL, as I'm going to use MySQL database. So Bal Persist init module name and the data store name. So when you click on Bal Persist init, so you can see there's Persist directly generated inside this hospital Ballerina project. Within that, you have the empty module Bal files. So this is where I'm going to model my uh, entities. So first, like I said, let's go and module patient's entity. Okay. So the patient can have ID field and name field, age, let's say phone number, and let's have address as well, and the gender. For gender, I'm use an enum. Let's define the enum also here. Enum, gender, male and female. Now that we define the gender, but you see there's an error here. So it says the entity must have at least identifier fields. So like I said earlier, there we can click on the quick fix. They list down all the fields that we can make it as identifier field. I will make the ID as the ID identifier here. So now that the patient record is done, let's go and create the doctor. The doctor, let's make the ID as the return primary key. We have the name, and we have the specialty, and yeah, we have the phone number. That's it. So then let's go and create appointment record. So there we will have an primary key as ID field and patient and doctor attached. So instead of using two different fields, I will going to use our time module civil record to record the appointment time, and we'll have a recent field, and we'll have a appointment status as again as a enum field. So let's do that. Instead of them, I have my own method started and ended. Okay. So okay, now that we defined, so you can see another error message popped here. It says the related entity patient does not have the corresponding relation field. Since we need to have bidirectional mapping between two entities, we only specified in one entity now. That's why we get an error. So if you click on the prefix, they give two suggestions, whether this is one-to-one relationship or the one-to-many relationship. As we need one-to-many relationship between patient and employee. Patient can have multiple appointments, and appointment can only have one entity, so I go with one-to-many. The same thing applied for doctor as well. So Now you can see in the doctor's record, there's an appointment field automatically created. And even for patient, we have this appointment field automatically created by the tool. Okay, now that we define all our records, so we can click on this at the top right top corner. There's a button called entity diagram. If you click on that, you can see the related relational diagram of the module we defined. So there's a doctor table, patient table, and the appointment table, and those are linked with one-to-many relationships. Okay, so now that we define the entities, the next step would be to generate the client APIs. So let's use Bal Persist generate command to generate the client APIs. Okay, now if you see, you can see there's another generated directory created, and within the generated directory, there's a DB directory created. Within that, you have this client bal file, the config bal file. This is the configuration we need to connect to MySQL. And these types contains all the types you need to use in the runtime in your application. And there's another file, like I said, there's a script file to create all the tables. So we have 3 tables here. So if I'm going to use this docker compose file to start our MySQL database, and here since our generated script is in generated DB directory, I mount this script file as a init script so that it will run automatically when we start the MySQL server. And also I create a data seeder file, and I also attach that one also to the init script so that it will also run, and data will be added into our database. And database will be hospital.db file. So if you go to the config.toml file, the configurations are already added here. So we just need to apply our changes here. Our user and our password. You can check on the compose file. This is the database name, this is the username, this is the password we given. Okay, now that I configured my application as well, let's create a new tab and run Docker Compose. Okay, those SQL scripts are executed and MySQL database is run correctly. Okay, now we don't need the compose, the config.toml file, and just keep the module.bal file for now. And here's our main.bal file where we are going to create a service. So here we use HTTP service, and our base part will be hospital, and the port will be 1990. So within our service, we'll create a client variable. So it's inside the DB module. So I import our DB generated module, and let's name it as DB client. So in order to initialize it, I'm going to use the init function. So here we use self.db client equal new. Here. So when initializing, there can be errors pops up. So I'll going to check here and add it in the return init return. So now that we initialize the DB clients, now we can use them in our other resource function. Before I jump into resource function, I want to highlight what scenarios I'm going to demonstrate in this demo. So I use this HTTPS client to send the requests to our service. So these are the requests I'm going to use. I'm going to create a new doctor. I'm going to create a new patient, create new appointment with the patient ID and the doctor, and get get all the appointment for a doctor for the given date, and get all the doctors with the specialties, and get the patient by ID, and get the status by update the status of the appointment and the delete appointment. Those are the operation I'm going to implement. So now that, okay, let's go and create one by one. The first one is to define the resource to handle post requests for the doctor, where we use resource function accessories post, and the path will be doctors, and the payload will, I'm using the generator type as a payload here, the doctor insert record type. So let's name it as doctor here. Okay, so now the signature is right. Good. Let's use our Persist DB client and call doctor post first, and it allows you to pass an array of records. Though since we have only one record, I'll create an array and pass it the single value here. And let's create the variables. Okay, let's rename this as result. Okay, it will return the array of primary key values, and also a persist error if we have error, if we get any error. So here we will first check whether it can persist error. Within the persist error also there can be different errors. It can be a connection error, it can be already exist error, etc. So I will check on already exist error. If it is already exist, we will just return HTTP conflict error. And if it is otherwise, we will return internal server error. If everything works fine, we will return HTTP created error. So let's populate the return types based on the return we have. So you can see all the return types are with the signature. So the next thing is creating a patient and an appointment. So for that, I get help from Copilot to populate my code, since the code is the same as creating a doctor. So the Copilot suggested the same thing I needed. So help for me to continue with the other resource functions. The next one is to populate the doctors. So that let's we'll create a resource function, and the accessor is get, and we have doctors path. There will be no input parameter. There is no query parameters we needed here. So we use again our DB client to get the doctors. So that if we create a variable, these things we don't need it. We just can remove them. And you can see we need to define a target type. So we can even use our generated target type, doctor target type, which is generated already. If you go to the generated type, it contains all the fields we define in the model. But let's say you don't need to get all the types, but one or two fields. That you can do by just defining another record inside your application and set only the fields you need. For this example, I removed the phone number field, and we use only three: ID, name, and specialty. And you can set the target type as what you define record type, so that it will get only the fields we needed. It's same as when you are writing a SQL query, we set a select what are the columns we just do the select query, and we specify what column we need to add. Similar that. So then let's return an array, convert this doctor stream into an array using our query syntaxes. That let's do from doctor in select doctor. We need to set here doctor array or just here. Okay, so that we define that get resource function as well. So I'm going to use another get function. I'm going to do another get by filtering at some filters also. I to get some to uh, save some times. I just going to copy one of these, as this is also another get function. So the get, so here what I'm doing is we are going to get all the appointments for the doctor ID by the path param and the date by query parameters. So here you can see the accessor is get and the path is doctor and the ID is passed at path param. And since we are populating the appointments, we have the appointment as also as the context, and we need to filter out from the given date. So the year, month, and date will be passed as query parameters. And here I will fetch all the appointments table, query the appointments table, and populate the appointment sheet. So here the target type is appointment. Uh, Here you can use even, like I said earlier, we get the generated types, but at the generate here, our purpose is to get all the appointments, and we need to get all the attached patients as well. So it's a kind of joint operation with the appointment table and the patient table. So I'm going to define uh, the required types here. Let's create an appointments record. It contains, let's see, let's first get the ID of the appointment, and we need the doctor ID to filter out that, and uh, we need to filter out from the given date. So we need the appointment time, and let's populate the status also here. Okay, so now it should be DB. So import the time module. Okay, so now what I need is we need to, when you fetch the appointment, we need to get the attached patients as well. So that we can use the patient field. Yeah, we can in our appointments record, you can see there's a patient field as well. We can use this patient field to populate the attached patients. So here I don't need to get all the details of the patient, so I just need to know the ID, a name, and the phone number. Let's say the phone number. Okay, now that we define the appointment, so I think we already used the same appointment. So one thing you should note here is when you are defining your own custom record, you need to the field name should be same as what we defined in the appointment record. So let's say, for example, we change name into a different one, the compiler will throw an error saying the target type is different from the expected actual type. So you need to be, the field name should be same as what we defined in the module. Now that we get all this data stream, and we can use our where clause, query syntax where clauses to filter out the doctor ID and the given dates. So I think this is okay. So now that we define that also, so let's quickly move into our next one. That is get by ID. So here also let's yeah, use this. I need to change a little bit here. So DP, I'm used the same or defined in the generated type, DP type, rather than specifying it. Here, instead of this, we will throw the ID as a path parameter. Okay. This will be DP patient. So we need to have. So if I explain this again, so what we are going to do is we fetch all the patient by ID. So ID pass it as a path param here. So same thing applied for a generated client as well. We use the same patient ID and pass the ID as path param. It will return a patient record and also and persist error whenever if there's any error message, you can use that. That one. So here if it is a patient record, we will return the results, or we will return the error message. So here we can even simplify this by just return here. We don't need these. Okay, so there are two more resources I planning to write these applications. It takes time, so I'll just copy these two resources for you, and I will explain what these resources are doing. So one thing, the other scenario I'm going to demonstrate is to update the appointment status updated record. So we are using dispatch accessor, and appointments we will get it as a path param, and as a payload we will get the appointment status. And you can see we can use this put resource function to update any fields in the record. So you don't need to specify all the record here. You can just specify what field you need to with the value. And if it is not found, we will give a not found error. If it is not, we'll give an internal server error. If everything works fine, we will return no content status quo. And the next one is delete. So what I need is here, we want to delete an appointment for a given patient for the given date. So the given patient ID comes as path param, and the date will come as query param. So like I done earlier, we fetch the appointments, and then we filter out the appointment based on the patient ID and the other appointment date. And this is the error filtering. And then once we get all the results, we iterate to the results and delete all the appointment which for the given date and for the given patient ID. And if everything works well, we will return our content. Okay, so now that we implement our service, let's go to the next step and do Bal run. Clean it up and then use Bal run. Okay, so while it's compiling, I just run through our application again. So we define custom record types, doctor and appointments for this to eliminate unnecessary fields fetching from the database. So this record is to add a joint query on appointment and the patient record. And we initialize our generated client and create a doctor and create a patient, create an appointment and get doctors and get doctor by ID and get appointments by doctor ID and the given date and fetch data from the patient, the appointments, and delete the patient and update the appointments. They did not delete patient, delete appointments, and here this we update the appointment. Okay, so the service is run successfully. Let's go and use our REST client to invoke them. First, we will create a doctor. Yeah, it's created all successfully, and let's create a patient. It's also created successfully. Let's create an appointment. It's also created successfully. Let's fetch all the doctors. So you can see at the bottom, you see our newly added doctor here. We have 6 doctors, and let's create the appointment field. So you can see this is our newly created appointment. You can see the patient record is also come with the appointment details. And then let's go get the details of the patient by ID. So you can see the patient records are come correctly. And let's update the appointments which newly added. So with the status as started. So yeah, no content means it's updated correctly. If you go back and fetch the appointment, you can see the status is now now set to started. And then finally, you can do a delete query for the appointment for the given patient. And the no content means it's already the operation successfully done. So if you fetch the appointment, you can see there is no appointment coming in. That means it's deleted correctly. So that's what I need to cover in my demonstration. So let's move to, so before winding this up, I want to cover the future developments of this area. So the Bal Persist module is kind of initial stages. So there are a lot of features we are planning in the roadmap. The first one is optimizing the query data through the generated client. Right now, we are not filter out in the DB level. Right now, we fetch all the data and do it in the in-memory. So we are planning to, our first priority is to optimize the query and move the filter queries to the DB level. That thing is currently going on, so it will be available in the future release, immediate future release. And the other one is supporting executing native SQL queries. So sometimes the generated client doesn't support your advanced queries you need to approve. For that to support, we are going to add another remote functions to execute the native SQL queries. And also, right now, we don't support marking auto-generated command flags to the identity fields. So that also coming very soon. And the other important thing is currently Ballerina types, which is defined in the model.bal file, is mapped to predefined types in the SQL database level. But we are going to support annotation kind of thing so that you can define to map any specific Ballerina type, which type you need to map it to the SQL type. And also we are trying to enable the transactions logs in the Persist module itself so that whenever you run the operation, you can see which SQL query we are generated and perform against the database so that it helps you to debug any issues you encounter. And right now we have very few data stores supported, MS SQL and MySQL in the RDB context. So we are going to support more. So we are planning to support PostgreSQL, Oracle, and MongoDBs, etc. Okay, those are the very high level roadmap in our. So if you have any question, feel free to ask. Yeah. So the question is, Malit asked a question, can you explain a bit more about the migration tool and how does it know how the migration is? Yeah. Let me move to the presentation slide. Okay. Okay. So the migration, how the migration works is, when we do Bal Persist migrate, uh, as you can see in the diagram here, inside the persist directory, we will create another directory called migrations. Within that, we'll create a uh, directory with the time we execute the command plus before that, I want to mention when you do Bal Persist migrate, we are asking for a label to uniquely identify the migration. So better you get a very good name so that you can identify, okay, this is based on for that migration. So let's say the initial module. So we create a directory inside this migration directory with the timestamp and the label you have given. And inside that directory, we copy the snapshot version of the current model we use for the migration. Let's say, for example, this is the initial migration. So we don't have any previous migration thing. So this one, copy the model current module.bal file inside this directory plus any SQL script. Here, the SQL, since there is no previous migration, this will be an init script, like we generated, create tables. So let's say we do some changes in this module.bal file and execute migration again. It will compare the latest module.bal file with the previous module.bal files in the immediate previous one. We are checking with the timestamp. So, and compare these two module files and identify the diff between them. And according to the difference, we'll generate the SQL script file and create another directory and update create a new SQL file with this alt tables. So if you have change new column or update new column, it will add an alt script here. So that's how we get the difference between the latest module file and with the previous. So we are maintaining this snapshot Bal file, snapshot version of the Bal file each time we create a migration. I think it's clear.
So the data migration happens, so the data is not getting.
No. Right now, data migration not happens, so we can't control that part yet. Only the schema migrations happens.
Right. Okay.
Okay. So since we run out of time now, I'm going to wind up this presentation. Before we wind up, if you are interested in this feature, there are a lot of documentation in the Ballerina website itself. We have a featured scenario where we cover like getting started guide. And if you need to explore more on this Bal Persist tool, there are different, we have documentation for different components as I explained. And in Bal Persist examples also, there are a lot of examples we added. So, okay. So if you have any question or if you want to engage more with this Ballerina community, there are a few channels we can connect to. One is the Discord channel. And if you have any questions, please raise them in the Discord channel as well. And we have this Stack Overflow collectives and Twitter and GitHub. Even you can create a GitHub issue. Okay, and thank you very much for joining. And if you have any questions, please raise them in the Ballerina Discord channel. Hope this session helps you and get some idea about our new feature. So thank you everyone for joining this session. Thank you.